this video is going to be a very I'm gonna try and prove using AA, SAS, and SSS, but I'm really not gonna do like a super formal proof like the T column with the stuff that you guys been doing, just because it's not really important right now. I just need you to get the hang of how to be able to actually prove it, right? Using at least some statements, like vertical angles or whatever stuff like that. Okay. So it's gonna be a very rough proofs. Okay, you're not gonna see like formal proofs like we've done before or like you did last year. But let's just go ahead and start. So if we understand, there's three different ways of doing it. Okay, you have AA, you have SAS, and then you have SSS similarity. What we can just do is just look at the diagram and decide, can one of these be eliminated already? And I hope that you can tell the SSS can be eliminated already because of the fact that you don't have anything for the missing sides. The only way for you to do SSS is if you have all three sets of sides that you can compare. Okay. And so what that basically leaves you is you can either do AA or you can do SAS. Looking at the information, looking at the diagram, we can already figure out an angle here. Um, that's that one right there, which is vertical angles. Okay, so we have an angle already. So we have an angle. And then in order for me to check off this A though, I can't just check it off. I have to make sure that it falls between the two S's that I'm gonna basically show. Okay, so you need to be careful. That is why I didn't already check that one off. And so let me just, slow down here, and can we figure out another angle here? For instance, do you have any right angles? Do you have any parallel lines? Never assume. Always just look at the diagram and what it's given to you. Okay. So we don't have any parallel lines. We don't have any like congruent angles that are right or anything like that. We don't have any other tick marks. So what this means is that I don't have another A. Okay? So since I don't have another A, that means I can't do AA. So then really the last option that I have is I have to do SAS. This process sometimes works, sometimes it doesn't. But it's a good jumping start if you really want to think about it. Okay, so let me go ahead and let's start with, I'm gonna do the A first, just because we already have it in the diagram anyways. Okay, so I'm gonna do the A first. I'm gonna do, let's see, angle FQE. Notice how I didn't just say angle Q because you don't know which angle I'm talking about. If I just say angle Q, am I talking about this one, this one, this one, or this one? Right? There's too many unknowns there. So you have to be very specific about which one is the one you're talking about, okay? And so then let's see, angle FQE is congruent to angle. Now, you can be super detailed about it and look at the names, the names given, so you can like scoop out the angle in the exact same direction. But honestly, for me, it doesn't really matter. Okay, you could have easily just said angle RQS as well. That is fine with me. All right, so now we have an A there. And just looking at the diagram, I can already tell it's in the middle of the two sides that I'm going to use. Notice how as I'm scooping out the sides that have numbers, the A falls in the middle, okay? So then that's the A. So one of the S's that I'm going to go ahead and do now, it's completely up to you, right? You can compare the FQ or you can compare the EQ. For whatever reason, let's just choose FQ, okay? So this is how we're going to do it, okay? Very basic, not super formal proof. So let's see the S. Let's do, since it's a side, I need to compare, like a ratio of the sides. So let's see, FQ is the first two letters, so that means I need to compare it to SQ. It's really important you get these two correct, because if you mix up sides, then it actually won't be similar. So this is going to be equal to 5 divided by 10, which is equal to 1/2. I mean, if you really want to, you can say 0.5. It's completely up to you. And now let's go ahead and if I do the other S, okay, so then that means it'll be, let's do right here, EQ or QE, whatever you want. I'm going to put EQ. And then we see EQ is the third and the second one. So it means it has to be the third and the second one. So it'd be RQ. So let's see, EQ is equal to 10. And then RQ is equal to 20. I know some of you guys, you probably saw this from the beginning. You're like, yeah, I know it's either half or times 2, depending on what direction. And so now what we're going to really do here is we're just going to, in a very basic way, right, show that the two S's, the ratios are equal to each other, and then we have an A, so therefore it actually is, okay, similar. One thing I did forget though is to write here by vertical angles. So don't forget to write that, okay, because basically think of it like the statement can't just come from nowhere and you're like, just believe me because I said it. Like, no, because they're actually vertical angles, okay? And so now this is what we're going to go ahead and do. I'm going to say 0.5 is equal to 0.5. So since, 0.5 equals 0.5, we have, sorry, that's supposed to say we. I know that says me. We have SAS similarity, okay, which we have an angle that falls in the middle based off of the diagram, not how I wrote it over here, okay? It's, you got to be careful. It's not how I wrote it over here. It's because it's in the middle of the two pairs of sides that I compared, okay? So we have SAS similarity. We showed that the two S's are equal to each other, and we showed the angle, which is congruent as well. And so now the last thing I can go ahead and just, write the similarity statement. So what this means is we can say, let's see, since 0.5 equals 0.5, we have SAS similarity. And so we can say triangle, and I already forgot the names. What is that? FQE, triangle. FQE is similar to, what is that? SQR. Okay, and this is just because I'm trying to be super, like I don't want you guys getting bogged down on trying to do a very, very formal proof. Okay, it's just trying to get it at least where you have a little bit organized, you have some sort of flow to it. Remember, this here is really important. You need to tell me why some of the angles are equal to each other. You need to tell me, well, what do I do with the 0.5 now? I compare them so they're equal to each other.